everyone. We are so excited to have you join us for today's Code Red Live Lab Challenge with Cloud Academy's very own Technical Lab Director, Logan Rockeye. In today's Code Red Lab Challenge, your AWS troubleshooting and security skills are being put to the test. If you have a Cloud Academy subscription, we recommend following along live with Code Red. Without further ado, the floor is yours, Logan.
Thank you very much, Tia, and welcome everyone to another live lab session here at Cloud Academy. Today we'll be going through Code Red Repair an AWS environment with a Linux Bastion host. And this is actually the first challenge that we created at Cloud Academy, and it's proven to be one of the more challenging ones. You do see that the difficulty level here is advanced. And for those of you who are following along, it does take a little bit of time to create all the resources for this challenge. So definitely try to smash that Start Lab button if you do want to follow along. I've already started this challenge ahead of time, so that's why my button says continue rather than start. It's just to make sure that everything's ready once we get into it. So just a quick overview of what we offer for labs here at Cloud Academy. This is a lab challenge, which is basically a type of hands-on assessment where we set up an environment and you have to go in and solve that challenge. There's no instructions telling you what to do. It's really just you showing and proving your skills, being able to complete the tasks in the challenge. That's in contrast to our more common guided lab, which is more for training purposes, where you have full instructions and we provide explanations and context to help you really remember and understand why you're doing things as you're learning. And the third offering is our lab playgrounds, which are our sandbox environments where you have free reign to try out and experiment things. Maybe you've just watched a course and you want to take things a little bit further. You can do that in our lab playgrounds. Okay. All of our labs are what we call batteries included. So we provide the accounts for this lab. It's focused on AWS. So we do provide the AWS account. You'll see a demo of that shortly once we get into it. For our labs, we do like to provide some quick visual representation. So I can just quickly show you the environment that gets set up so you can have some idea of what's going to happen in this challenge. So basically, we'll have our SSH client connecting to the Bastion, and we want to go from the Bastion to the backend server, which is in a private subnet, but the connection fails. And that's cause for the code red alarm. We have to go in and figure out what's wrong and try to resolve the issue. Okay, so the final result, we can connect to that backend server. Okay. So with that, I'm going to click on Continue Lab. This will load up the actual mission statement for the challenge. So each challenge will have a mission that you need to accomplish. I'll quickly just read through this. So a security report discovered that administrative access was unintentionally granted to an account in your AWS production environment. The unintended permissions have now been revoked. However, your operations team has informed you that you can no longer connect to the backend instances over SSH via the Bastion host. You also have the following diagram to help remind you of the basic architecture. So let's take a look at this. Obviously, we're in AWS. We have a single VPC, which has an internet gateway, and there's two availability zones, okay, 1 and 2. And there's public subnets and private subnets in each of those availability zones. We have the Bastion instances, which are part of an auto-scaling group, and we have the backend instances, which are running your workload. There's also elastic IP addresses and public route tables being configured. That's what we can tell from the diagram. We also know that the CIDR for the VPC is 10.0.0.0/16. So all of these things will be helpful and worth keeping in mind as we go through. So you must repair the environment, which is your lab environment that we'll connect into soon, and make all the checks pass before time runs out. And then there's some quick instructions here to how to sign into the AWS account that we provide. Verify that the CloudFormation stacks, which actually deploy the environment, are created completely. And with that, we can go to the validation steps. There's a couple of hints here. So just to explain things, for this challenge, there's 4 checks. 3 of them pass by default, so without having to do anything. Those checks are just there to maintain best practices. So there's potentially different ways to solve this challenge. Some of them are not best practices, however. So those checks that are passing automatically, we want to make sure that they stay passing, and that ensures that we are not breaking any of the best practices. Also, one final hint here that you do not need to connect into the instances to repair connectivity. So that suggests that the issue is with the AWS resources and not something at the operating system level. So with that, let's go ahead and I'm going to copy the password for the account that we provide. The username will always be student for AWS Labs, and then we can click Open Environment, and this will open up our AWS login. We'll sign in with that password, and now we're connected in. We'll just start by going into CloudFormation. So type CFN, find CloudFormation, and from the CloudFormation console, we can see those stacks that have been deployed. So this is using the nested stack architecture for CloudFormation. So there's the parent stack, Cloud Academy Labs, and within that, it deploys a VPC stack, a Bastion stack, and a backend stack. Okay, so one stack for the main groups of resources in this architecture. We can actually get started by talking about some of the services that you won't be able to leverage, but maybe in production you would leverage. So to make this challenge a bit more difficult, you don't have access to all of the services that you may think about using. The ones that I'll mention are VPC flow logs and reachability analyzer. So I'll just quickly open up a new tab at the VPC console, and we'll just give a quick brief on what these services are, because we're not going to use them to solve the challenge, but in practice, they could be quite helpful. The first one is, so I'll filter just to the Cloud Academy Labs VPC, and then view our VPCs. First one is the VPC flow logs. So flow logs can create a log of all the IP traffic within your network, and it can be deployed at different levels. You can enable it for the whole VPC as needed. For this challenge, you can decide to log all traffic or only accepted traffic, only rejected traffic. Given this challenge is about failed connections, you may decide to only filter rejected traffic. And then you can view the results in CloudWatch logs, S3, or using Kinesis Firehose. A quick preview of what these logs actually look like. This is a bit dated, but this is from an AWS blog. But you can see it basically gives you the source IP address, the port, destination IP, destination port, the time, whether they were accepted or rejected. So using this information can be quite helpful for identifying any issues. AWS documentation provides a full list of all the fields that are included by default. Okay. That's all that I'll say about this. You don't have permission to use this for this particular challenge. The other one I want to mention is reachability analyzer, and this one may be more pointed and directly get you to the answer for this challenge. I'll just write path as the name, and you can choose where you want the source traffic to come from. So we want from our Bastion instance, and we want to target one of the backend instances. And we want SSH, so you could fill in TCP port 22, that's SSH. And then create and analyze the path. And that will generate a diagram that looks something like this. And if somewhere along that path, so this is going from the instance out of its network interface, through the security group, through the network ACL, through the route table to the destination, which in this case is an internet gateway. If anywhere along that path something got rejected, it would, succinctly tell you where that failure is. So that could really quickly highlight what the issue was. One thing worth noting, it may not be directly useful in this case. You may, if we recall this later on after we solve the challenge, I'll try to talk about it, but you should analyze both directions. So that's just a little bit of foreshadowing. Okay, so all that being said, those are the two things that may be helpful in practice, but they're not allowed for this challenge. So let's continue on with what we do have access to. So I'll go back to CloudFormation. This is a useful starting point. So just to get the lay of the land, you can use CloudFormation directly to provide you with a table of all the resources that are created, and we'll come back to this. You can also get a visual representation if you go to Template and then View in Designer. Okay, and this always slides off my screen, so I zoom all the way out and then scroll down, and here you can see all the resources that get created. Now, this is one of the challenging parts with this particular challenge, is that there is quite a high degree of complexity. And obviously, it's a time-limited challenge, so you won't have time to go through and analyze all of these resources. You'll have to leverage your networking knowledge to know which could be potentially impacting the connectivity and which are really just distractors. So things that are there, but not really going to have any impact on the connectivity from that bastion to the backend instances. So that being said, I'm going to exit out of the designer. And I'll go back to the VPC stack resources. And we'll just order it by type and see what we have here. Some of these were already previewed in the architecture diagram. So there's Elastic IPs, Internet Gateway, NAT gateways, network ACLs. That's one that's worth noting because network ACLs can allow or deny traffic. The routes, so if the routes are messed up, but potentially the connection couldn't be established. Here's a corresponding route tables that house those routes. And then there's route table associations. And then there's more distractors. So VPC endpoint won't be impacting the connection from the back bastion to the backend instance because they're in the same VPC. Then if we take a look at what's in the backend and bastion stacks, as far as what could impact that connection, mainly it'll be security groups. So another way of allowing and denying traffic in AWS, the security group. And we'll get into the differences between security groups and network ACLs a little bit later. But if I just look at the backend stack, it's similar. Mainly just the security group that could be impacting the connection. Okay, so we kind of highlighted security groups, network ACLs, and routes as potential issues. I'll just start with the routes, just in a random order here. So if I go back to the VPC and I choose route tables, by default, route tables will have a local route that allows traffic within the VPC to reach each other. So we'll just verify that those routes still exist. You'll see the VPC side address and the local target. That's your local route that allows instances within the same VPC to connect with each other. So we'll just quickly verify that that's always there. So local, 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 local. So that tells us that the route shouldn't be a problem because there is that local route for every route table, irregardless of which route table is assigned to what subnet. All the route tables have that same route, so it shouldn't be a route issue. So we can cross that off our list. Next one we should get into is security groups and network ACLs. So we can see both of these from the VPC console, some network ACLs, ACL's access control list. And we briefly touched on it, but they're at different levels of abstraction. So network ACLs apply to a subnet, and security groups apply to instances or the network interfaces of instances. Security groups only have allow rules, and network ACLs you can apply allow or deny. So here's an example for the default rule of an ACL. We have allow rules, which has a higher priority. So anything will be allowed by this rule. And then there's the default deny rule, but you can create deny rules that have higher priority. That's another thing, that the network ACLs have a rule number, or basically a priority for how the rules are evaluated. With security groups, all the rules are evaluated, and if none of the rules allow the traffic, then it's rejected. For network ACLs, you go through rule by rule and whether it's allow or deny in that priority. Okay, and then a big difference that I'll summarize and wrap up with is that security groups are stateful. So return traffic in a connection is inherently allowed without any explicit rule for that. With network ACLs, they're stateless, so it won't know if the traffic is return traffic or it's originating traffic. And that'll be an important thing to remember for this challenge. Okay, and just to illustrate the connectivity issue a bit better for this challenge, I'm going to actually sign into the Bastion instance. So if I go to the EC2 console, I'll get the IP address of the Bastion instance. So IP, or the public DNS. So I'll copy that. And with Cloud Academy, we provide the PEM file right from our interface. So this is the key that you'll need to SSH to the instance. So I'll download that. I have a terminal open here and zoomed in so that you can hopefully read it. Go into my downloads folder and change permissions so that SSH doesn't complain about the key file having too many permissions. So I'll do 400 for the permissions. And then because we're looking to use the Bastion to connect to the backend instance, we want to use SSH agent forwarding. That way we can have only this copy of the key and use it from the Bastion to the backend without having a separate copy of the key on the Bastion. So a convenient way to do that is with SSH add. So I'll add that key. So that's now added, and we can use SSH agent forwarding with that key. So if we go back to the EC2 console, we can see that these instances are Amazon Linux. And it's worth highlighting that you don't actually have to connect to these instances for this challenge, but I'm just doing this so that we can illustrate the actual issue. But with Amazon Linux instances, the default username is EC2 user. So I'll just put EC2-user and paste in the IP address. And there we go, we can connect to the Bastion from the public internet. Now the next step would be trying to connect from the Bastion to one of the backend instances. And that was the problem that's highlighted for this challenge. So I'll get the private IP. There won't be any public IP for these backend instances in private subnets. So if I just try SSH, and they're also Amazon Linux, so they have the same user. I won't need to specify the username. If I try to connect, it'll just eventually time out. Nothing gets established here. So that verifies the issue that we're having. And if I go back to the lab itself and run the validation checks on the validation steps tab, we can have the validation checks also confirm this. So the first check is testing if we can connect from the Bastion to the backend instance. And it turns red, so that means that we can't. There is a hint here, but to keep this as real world and practical as possible, I won't use that hint. You're always free to use the hints that we provide, though, if you do on your own. But just focusing in on this challenge, we can't get from the bastion to the back end. So let's take a look at what could be interfering here. We'll start with security groups. So security groups can be viewed from the EC2 console as well as the VPC console. If you go to from the EC2 console, if you're on an instance, you can select security tab, and you'll see the security groups that are associated. So here we have the backend instance has one security group, and it has the inbound and outbound rules here. So inbound is allowing port 22 TCP, so that's SSH. From the source, which we could look up and determine that this source security group is actually the group for the bastion. So this security group basically says we're allowing SSH from the bastion security group, which is what we want. There's also ICMP, which allows ping to work on the network, and outbound has everything allowed. So from this perspective, the backend security group is allowing SSH. So that's pretty much all that we needed. If we look at the bastion, we can see what the security group rules say here. We have, again, there's a rule for ping that'll allow the ping to work within the network. And then we have inbound SSH allowed from anywhere. So that allows us to connect from the public internet to the bastion. And we verified that that does work already, so that's good. And outbound, just not that it's really important, but outbound allows everything. So that won't be impacting our connectivity. So we can essentially at this point cross off the security groups as being the source of the issue. And it could be a potential head scratching moment here because within the EC2 console, there's no reference to the network ACLs, but you do have to always keep in mind that network ACLs are another layer that can be impacting connections. And we'll have to go to the VPC console to see those. So here we have the network ACLs already. We have two, I'll just filter to only the labs VPC. We have one default network ACL, and by default, ACLs are going to allow all traffic. So the first rule allows all protocols, all port ranges, all sources. This VPC isn't using IPv6, so there's only the IPv4 allowed, and outbound is allowing everything as well. So that looks good. That won't be causing any connection issues because everything is allowed. Then we do have the NACL protected subnets, and this is being applied to two subnets, which are our private subnets. Okay, and those private subnets, recall, host the backend instances. If we now look at inbound rules for the NACL protected subnets, NACL, we see the same rules as a default. So inbound allowing everything, outbound, the second rule never applies because the first rule covers all traffic. So everything gets allowed. This could be another head scratching moment, but remember that NACLs, unlike security groups, aren't stateful. So return traffic isn't inherently allowed. We have to also consider potentially the outbound rules being the cause of the issue. And in this case, we have more interesting rules to look at. We have outbound SSH, HTTP, and HTTPS. Now, this is where some of the deeper knowledge of how TCP and connection-oriented traffic works. This rule here, allowing outbound SSH, is really for SSH connections that originate from the backend instance. It's not applying to the traffic that's returning when we make a connection from the bastion to the backend. So this is actually the main issue for this challenge. And if we just talk a little bit more about that connection-oriented traffic, in TCP, your packets will include a source and destination. For our case, the source is the bastion and the destination is the backend instance. And both are described by both an IP address and a port. So the destination is obvious. It's the backend instance IP and port 22 because that's where you connect on SSH. The source IP is also obvious. That's the instance IP address, which would be the private IP because we're doing the local connection. But the source port is the catch here. So the source port won't be 22. The source port will be drawn from what's called the ephemeral port range. So whenever you try to establish a connection, there'll be a port pulled from that available range. And that's the catch for this challenge. I'm going to reference the AWS documentation for network ACLs. So you can feel free to read up more on any of this, but the main part here is this ephemeral port range. So that's what's not allowing the return traffic for that SSH connection to establish because we're only allowing SSH port 22, HTTP port 80, and HTTPS port 443. But that doesn't overlap with the ephemeral port range. So for Amazon Linux, which is what we're using, we have the ephemeral port range of 32,768 all the way up to 61,000. And for different distributions, operating systems, you have the port ranges for ephemeral port ranges here as well. If you're not into looking at the docs, you can get this range from the instance itself. So if you cat out /proc/sys/net/IPv4/IP local port range, this will give from the instance itself the actual ephemeral port range. So this goes all the way up to 61,000 -1. So that corresponds to what we found in the docs. So this range has to actually be allowed by that NACL for that return traffic to be allowed through the NACL. So let's go back and edit the rules for the NACL. So we don't want to just allow everything just from a security perspective. We want to try to just allow the minimal necessary, which is just that ephemeral port range. So we'll try to do that. Add a new rule. The priority doesn't matter so much here. I'll just say 200. 32,768 to 61,000 was the ephemeral port range. And the destination, we don't want these backend instances reaching out anywhere outside the VPC. So we'll scope the destination to just the VPC, which is 10.0.0.0.16. That's the CIDR address range for the VPC. And we'll allow that traffic. So once we save this, we now are allowing that return traffic to come from the backend to the bastion. So here it is. So let's actually go back to our terminal and try to establish the same connection. And there we go. So we have a response rather than having it hang because that return traffic is now allowed to the NACL. Okay. If you're curious what port was used by the source, so in this case, our bastion, you can actually see that using the netstat utility. And we'll use N for numeric ports and T for only TCP. And we have only one connection here, which is the SSH connection from the bastion to the backend. So this local address, we're on the backend instance right now. So that's the IP address of the backend instance on port 22. But the foreign address refers to the originating bastion host. So this is the IP, private IP of the bastion. And this is the ephemeral port that was drawn. So this does fall within that 32,768 to 61,000 port range. So you'll always have that ephemeral port being used for SSH. Okay. Now let's go back to the Cloud Academy interface and we can run the checks. If I just quickly preview, the hint was talking about network ACLs. So we probably could have figured out from that hint directly, but it was a good exercise to just review all the different resources that are involved with establishing connectivity in AWS. Okay, so now we do have our checks passing. All four of them are passing. So the last three we have were there only to ensure that best practices were maintained. The descriptions are vague though, they don't tell you what they're checking. I can highlight to give you a bit of insight on what they're actually doing. So the first one, if you were to remove the network ACL entirely and just use the default one, that's kind of not a security best practice because you want to try to just limit the traffic to what's required. Next one would be if you had to modify the security groups. There was nothing wrong with the security groups. They were allowing the SSH connections, which is all that was required. And the fourth one, you could establish a connection to the backend instances if you were to make the private subnets public, which is a no-no for sure. So if you added a route for the private subnets to the internet gateway, they would no longer actually be private subnets. But you could probably, hack a solution like that. But the best solution that adheres to all the best practices is just modifying the NACL to allow for the ephemeral ports for the return traffic. Okay, so that's everything for this challenge. Hopefully it was insightful and a good review of the different network resources that can impact instance traffic. I'm going to open up for the questions. I see a couple of questions have came in already. If you do have more questions, feel free to drop them in the chat. But to start with, we have if the bastion wasn't using the default NACL, what rules would you add? So that's correct that the we had the default NACL being applied on the bastion, not on the backend instances. So if we had a less permissive NACL for the bastion, at a minimum, you basically would need kind of the opposite of what we had for the backend instances. So you would need to allow outbound SSH, so port 22 within the VPC, which is 10.0.0.0/16. So that would allow the bastion to send that SSH packet to the backend instance. And then for the incoming traffic, you'd have to allow the ephemeral port range back to the bastion. So the 32,768 to 61,000 port range. And again, you could scope it to just 10.0.0.0/16 so that only within the VPC that connection could establish. But because it is a bastion instance, we had to connect to the bastion from the public internet. You'd have to also consider that. So you'd have to have something allowing SSH from the public internet. So it wouldn't be quite as restricted as the backend NACL was. Okay. And next one, if issue on the instance wasn't ruled out by the hint, what would need to be checked? So that's right. There was a hint that's described that the you didn't need to connect to the instance to repair connectivity. So what if that wasn't the case? In that case, you'd be looking at the instance firewall. So these are Linux instances. So IP tables, the most common, but you have also higher levels of abstraction depending on your Linux distribution. So firewall D or UFW. Those would be probably the best place to start. Just check the local instances, firewall rules. Those could be the other source of the issue. In this case, it was ruled out by the hint, but there's the possibility that there was an IP firewall rule, in IP tables, that would deny that traffic as well. Okay. I don't see any other questions, so I'm going to wrap it up here. And thanks again. I hope everybody enjoyed the live lab session. I'm going to pass it back to Tia, but thanks again, everyone.
Perfect. As Logan has said, there doesn't seem to be any more questions coming in. So I just want to say thank you, Logan, for your time and your expertise. Additionally, thank you all that joined us today. We hope that you found walking through the lab with Logan helpful. At this point, this concludes today's webinar. We hope that you have a wonderful day and that we get to see you again soon. Bye-bye.